Our next topic is congruence through constructions. So what we're going to be doing is using a compass and a straight edge to make some geometric constructions, and we'll also be looking at some triangle congruence theorems that go along with those constructions. You'll see constructions in 7th grade in the Common Core State Standards, and you'll notice that it describes constructing triangles, constructing other geometric shapes freehand with ruler and protractor, and also technology. So we're going to start with constructing a circle with a radius equal to line segment AB. So we'll start by thinking about what makes a circle a circle. A circle is defined to be the set of all points that are equidistant from a point that's called the center of the circle. So the first thing we're going to do is draw a point to use as the center of our circle. So there it is, that's the center. And the next thing we need to do is measure the distance from point A to point B. Now, measuring does not mean you're going to use a ruler. Measuring means you're going to take your compass, put one end of the compass on one end point of the line segment, and then stretch the compass out until the other end of the compass is on the other end point. So now we can say that this compass is measuring the length of line segment AB. If we move the compass over to that point that we want for the center of the circle, and then draw around that point, what we're doing is drawing all of the points that are the same distance from that center. And since we measure that distance by measuring the length of line segment AB, we now have a circle that has a radius that's equal to line segment AB. For the rest of the constructions we're going to look at in this video, we're going to see how those constructions are done on a website, and you will have the URL to that website at the end of this video. So I'd strongly suggest you go to the website, take a look at the constructions that are there, and see how the constructions are done so that you can do those same constructions with your compass and protractor. So the next construction is construct a line segment that's congruent to another line segment. This construction is also known as copying a line segment. So we're starting with line segment PQ, and we measure the length of the line segment with the compass. Mark an arc and a point on the arc, and then connect the 2 points up with a line segment. And line segment RS is now congruent to line segment PQ. You'll notice that in all of these constructions, when we measure, we're always measuring with the compass. We never measure by taking a ruler out and using the marks on a ruler. That's not considered measuring in constructions. Now let's look at a way to construct a copy of a triangle. There's several ways to do that. So we're going to start with a construction that builds on what we just saw in terms of copying a line segment. So let's start with a triangle. We're going to measure one of the sides and draw an arc, put a point on that arc, measure the second side and the third side. Where those two arcs intersect represents the third vertex of the triangle, and now we can just connect up the vertices with line segments. Now the construction we just saw is an example of the side-side-side theorem, which says If three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. So through the construction, we made two triangles that had three sides that were congruent to each other, which means by the side-side-side theorem, the two triangles must be congruent. Now, when you look at congruent triangles, you can talk about the parts of those two congruent triangles that must be congruent to each other. So if we have two triangles that are congruent, in this case triangle ABC, which is congruent to triangle EFG, then we know that angle A is congruent to angle E. Now we know that not from the picture, we know that from the congruent statement. So when we see triangle ABC is congruent to triangle EFG, there is implied in that statement which angles are congruent to each other. Angle A is mentioned first in the name of the first triangle. Angle E is mentioned first in the name of the second triangle. So those two angles would have to be congruent. Likewise, angle B has to be congruent to angle F. Those are the angles that are measured second in the name of each triangle. And angle C and angle G have to be congruent. Those are the angles that are mentioned third in the names of each of these congruent triangles. If we have these two congruent triangles, then corresponding sides are also congruent. So side AB is congruent to side EF. Once again, if you look at the names of the triangles and you look at the order that the letters are mentioned in the names, AB would be the first and the second vertices that are mentioned in the first triangle. E and F are the first and second vertices that are mentioned in the second triangle. Those would have to be congruent. Segment AC and segment EG must also be congruent, and segment BC and segment FG would have to be congruent. So when we have two congruent triangles, we have lots of parts of these triangles that are congruent. And in fact, because of that, we can say this congruence in a way that we can also abbreviate. So we can say that the corresponding parts of these congruent triangles are congruent. And when we start doing congruence theorems or do proofs, we're going to abbreviate that phrase as CPCTC, meaning corresponding parts of congruent triangles are congruent. So another thing we can talk about with triangles at this point is the triangle inequality. And that says that if we know the measures of three sides of a triangle, that the sum of the measures of any two sides have to be greater than the measure of the third side. So if we have three sides and we're claiming that these three sides could be sides of a triangle, we have to think about how we could put them together to make a triangle. So if you imagine these three sides that we would try to put together to make a triangle, what would happen if we tried to make the ends of the red line segment and the blue line segment meet to make a triangle? What we'd see is that if we try to make those ends meet, they couldn't because they're not long enough to touch. And the reason that they can't meet is that the sum of their measures, the sum of the length of the red line segment and the length of the blue line segment, is not greater than the measure of the yellow line segment. So let's go back to constructions. Let's see how to construct a copy of an angle. Now, one thing to remember again when it comes to constructions is that when we measure something, we do not measure it with any sort of tool that has marks on it. So if we're going to measure an angle, we don't measure it using the marks on a protractor. We're going to measure it in a different way. So here's the angle we want to copy. We're going to draw a ray to represent the bottom ray, and then make an arc on the original triangle through both rays. We'll duplicate that arc on our copy and then measure from the intersections from K to J. Copy that measurement onto our copied angle and then connect up point P with that intersection that we drew. And now we have the angle copied. So let's put some of these constructions that we've just done together to construct a triangle that has side lengths congruent to two line segments and an included angle congruent to a known angle. Included angle means that the angle will have as line segments on either side of that vertex, line segments that are equal to the length of segment EF and segment GH. So that angle will be between those line segments. So let's start with our two line segments and our angle. We'll draw a ray to represent one side of the triangle and measure a side. Now we're going to copy this angle to one of the vertices of our copied triangle. And then we'll have to copy the measure of the other side of the triangle and then connect up the intersections for the third side of our triangle. So the construction we just saw is an illustration of another triangle congruence theorem called side angle side. This theorem says that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles must be congruent. Let's see how to construct a perpendicular bisector of a line segment. Now think about the words perpendicular and bisector. Perpendicular means we're going to construct something that is at right angles to this line segment. And bisector means we want to construct that perpendicular so that it cuts line segment AB exactly in half. So it will go through the midpoint of line segment AB. Now once again, remember, just because you have a protractor that has a measurement on it that says 90 degrees, you can't use that to construct a perpendicular. You cannot use those measurements on those tools. So let's see how we're going to construct a perpendicular bisector. There's our line segment. We're going to stretch the compass out more than half the length of that line segment and make arcs above and below. And then without moving the compass's position, we're going to do the same thing from the other side of the line segment. And then if we connect up the intersections of those two arcs, what we'll have is a line segment that is perpendicular to line segment PQ, and it also cuts line segment PQ exactly in half. Now because this construction allows us to make a 90-degree angle, it's going to be a good construction to remember how to do anytime we're asked to construct something that has to have a right angle in it. So if we're asked to construct a rectangle or a square or a right triangle, all of those things have right angles in them. So this would be a construction that we could use to create that right triangle in our construction. So we've constructed a bisector of a line segment. Let's see how to construct a bisector of an angle. That would be a ray that cuts the angle exactly in half. So remember, to construct a bisector of an angle, we can't use the protractor to measure how many degrees are in the angle and then use that protractor to construct something that will bisect the angle. We have to make these constructions without using those marks on the tools. So here's our angle. We're going to draw an arc that goes through both rays of the angle, and then put the point of the compass on the intersections we've created and draw arcs out in the middle of the angle, which, when we draw a line segment from the vertex of the angle to the intersection of those two arcs, that line segment will bisect the angle. So let's try another triangle construction. Let's construct a triangle with angles congruent to angle A and angle B and included side congruent to line segment GH. So included side means that this side has to be between the two angles. So we've got two angles and our side. The side we're going to copy first. So we use the compass to measure its length and copy that length. Then we need to copy each of the angles to the end points of the line segment. And we do that with the same procedure that we used before to copy an angle. And then we copy the one on the opposite side. And there's our triangle. So this construction is an example of another triangle congruence theorem that's called angle side angle. And this theorem says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So since we constructed two angles and an included side that were congruent to these angles and an included side, then we know that we have constructed the parts of a triangle that are congruent to the triangle that can be made with these pieces. So that's all the constructions we're looking at for now. In order to take a look at the constructions that you've just seen online yourself, if you look at the URLs at the bottom here for Math Open reference constructions, if you want to look at those yourself, and there are more constructions there, please feel free to do that. And make sure that you bring your compass and your protractor to class, because we will be practicing these constructions with our own construction tools.